Hello guys, this is the lecture number 6 on limits, and in this particular lecture we will solve a lot of problem in limits, and those problems are very important for your academic purpose and also for any entrance exams purpose, right? So let's start the video by showing you the previous example which we didn't solve in the previous lecture 5, right? Basically I gave you some hints to solve this question, but I believe that there will be some person who actually didn't solve this particular question, right? So how we can solve this question? So basically here you can see that the first term is 2 to the 20 to the power x minus, right? So we can basically break this 20 as 5 times 4, right? So now we can write down this thing as limit x tends to 0 5 times 4 to the power x minus 5 to the power x minus 4 to the power x plus 1 over sine square 5x, right? So we know, right, a times b to the power x can be written as a to the power x times b to the power x, right? So we can write down this particular limit as 5 to the power x times 4 to the power x minus 5 to the power x minus 4 to the power x plus 1 up over sine square 5x, right? So basically we have to take the first two function here, then we have to take another two function here. So basically if we take the first two functions which are actually on the numerator, and the functions are actually 5 to the power x times 4 to the power x minus 5 to the power x, and if we take common only 5 to the power x, then what we will observe is basically 5 to the power x times 4 to the power x minus 1, right? And if we take negative 1 common from negative 4 to the power x plus 1, then it will be negative 1 times 4 to the power x minus 1, right, over sine square 5x. I have already told you this thing, right? So basically this thing will become limit x tends to 0 on the numerator. If we take common 4 to the power x minus 1, we will have 5 to the power x minus 1 times 4 to the power x minus 1, and on the denominator we have sine square 5x, right? So basically here you can see that on the numerator there are two functions multiplied with, right, and the functions are in the form of a to the power x minus 1, right? And on the denominator we have two sine functions, right? I mean sine square function. So we can divide these by x square, right? So divide the numerator and the denominator by x square, right? So when we divide the numerator and the denominator by x square, it will become limit x tends to 0. On the numerator we have 5 to the power x minus 1 times 4 to the power x minus 1 over x square, and on the denominator we have sine square 5x over x square, right? So first of all we can see that there is a function on the numerator and also a function on the denominator, right? So we can separate the limit on the numerator and the denominator, right? So if we separate the limit on the numerator and denominator, so it will become limit x tends to 0 5 to the power x minus 1 times 4 to the power x minus 1 over x square, and on the denominator we have limit x tends to 0 sine square 5x over x square, right? So now you can see that that particular function can be written as 5 to the power x minus 1 over x times 4 to the power x minus 1 over x, right? Similarly the denominator can be written as limit x tends to 0 sine 5x over x whole square, right? Is that right? So now we can actually take the limit on the two functions, so it will become limit x tends to 0 5 to the power x minus 1 over x times limit x tends to 0 4 to the power x minus 1 over x, right? And on the denominator we can apply the formula which is known as limit x tends to 0 any function to the power any constant term can be written as limit x tends to 0 that function whole to the power that constant term, right? So we have to apply the formula on the denominator, so that will have limit x tends to 0 sine 5x over x that part whole square, right? So here we have space, right? So let me write down the answer of in that particular space. So it will become, that particular thing is nothing but log base e and 5, right? Similarly that particular thing is known as log base e4, right? And on the denominator we know limit x tends to 0 sine kx over x can be written as only k, right? Similarly sine 5x over x can be written as only 5, right? So that will become 5 square, right? Because 5 that part whole square should be there. So since there are multiplication of logarithm, that can be known as limit e 5 plus 4, because multiplication can become addition, right? So that will be 5 plus 4, and on the numerator we will have 25, right? So that will become log 9, right? That will become log 9 over e to the power by 25, right? You can also break that 9 to 3 square and it will become 2 log 3 over 25, but that is not you have to do. Basically this is the solution of that particular question, right? So what we did actually break that 20 into two parts, which is 4 to the power x into 5 to the power x, and we will take common, we will divide the functions on the numerator and the denominator by x square, and after that we will solve this particular function into some theoretical manner, what we did actually, right? Yeah, so let's move to the next question. I mean next theory, which is known as something f to the power x type, f to the power g type theory. What this theory says, if limit x tends to a, fx will be there where a belongs to real number, I mean that a is belongs to real number, is of the form 0 by 0. I mean if you will have any kind of function, I mean you can say that this function is a kind of another function over another function. I mean this is a kind of rational function, right? So if we will have any kind of function, and after putting the value of x as a, if we will observe that particular function will give me 0 over 0 type of formation, what we actually had in our previous lots of examples, then what we have to do, basically there should be a necessary thing, which is a should not be equals to 0. If a should be equals to 0, then that will be, we can make that thing into some forms, right? So we don't need to think about the forms or something. But when x tends to a, I mean a is non-zero, then how we can solve the question when 0 by 0 form will appear, right? So the method says, like, we have to let x minus a as t, right? X minus a as t. So as x tends to a, then x minus a will tends to 0, because I mean x minus a will tends to a minus a, right? X minus a will tends to a minus a, which is nothing but equals to 0, right? So x minus a tends to 0, so t equals to x minus a, so t also tends to 0, right? So as x minus a equals to t, x tends to a implies t tends to 0. So we have to change the variable x as t, right? So we have to change the variable x as t, we have to change that variable x as t, right? So let's do the problem which is written on this particular slide, which is limit x tends to 3 e to the power x minus 3 minus 1 over x minus 3. So how we can solve this question? Basically here you can see that x tends to some non-zero value, right, which is actually 3. X tends to 3, which is a non-zero value, right? So what we have to take, let let x minus 3 as t, right? Let x minus 3 as t. So can we say that as x tends to 3, t tends to 0, right? As x tends to 3, t tends to 0. So that particular function written as limit t tends to 0 e to the power t, right? Because x minus 3 is nothing but t, negative 1 over t, right? X minus 3 is nothing but t. So it will be of the form e to the power t minus 1 over t as t tends to 0. So that is nothing but, you know, right? That is equals to 1. So the value of this particular function is nothing but 1, right? So let's move to another question. This is a kind of advanced question. You can solve this by your own. I will give you the solution. So before that, you have to try to solve this question by yourself first. So I will give you a little bit time, a little bit seconds, so that you can think about this question. So please think about this question, and after that we will solve, or we will give you the detailed solution of that question, right? Okay, so basically here we can see that x tends to pi over 6, right? And you know, pi over 6 are non-zero value, right? Since pi over 6 are non-zero value, so let x minus pi over 6 equals to t, right? So as x tends to pi by 4, then where t tends to? T should tends to 0, right? So let me change that particular limit in terms of t, right? So it will become limit t tends to 0. On the numerator we will have 2 minus root 3 cos, right? Cos, it will become, so what will be the value of x? X is nothing but t plus pi by 6, right? I mean pi by 6 plus t. We can write down this as pi by 6 plus t, right? Similarly, we can write down this as sine pi by 6 plus t, right? On the denominator, we can write down that x equals to t plus pi by 6, right? So that can be written as 6 times t plus pi by 6, right? Minus pi whole square, right? We can write down this particular function into that particular function, right? So it will become limit x tends to, t tends to 0. It will be limit t tends to 0. On the numerator we will have 2 minus root over 3, that will become, we know, right, the formula of cos a plus b, right? I will written down here that cos a plus b is nothing but cos a, right, cos b minus sin a and sin b, right? So cos pi by 6 plus t can be written as cos pi by 6 cos t minus sin pi by 6, right, sin t. Similarly, we know the value of sin a plus b, right? Sin a plus b, right? It is nothing but sin a cos b plus cos a, right, sin b. So here sin pi by 6 plus t can be written as sin a cos b, right, cos a plus cos a sin b, right? Similarly, on the denominator we can multiply this t plus pi by 6 with 6, so it will become 6t plus 6 times pi by 6. That can be written as only pi, and minus pi is there, right? So that will become 6t plus pi minus pi. So pi and minus pi will be cancelled out. So it will become limit t tends to 0. On the numerator what we will have is 2 minus root 3 times, can you please tell me what is the value of cos pi by 6? Can you tell me? The value of this cos pi by 6 is nothing but root 3 over 2, right? The cos pi by 6 is nothing but root 3 over 2, and cos t will be there, minus, can you please tell me what is the value of sin pi by 6? I mean sin 30 degree, right? Sin 30 degree value is nothing but half, right? 1 over 2, and sin t is there, right? Negative symbol, sin pi by 6 will be half, it will be cos t, right? Plus cos pi by 6 can be written as root 3 over 2 sin t, right? And on the denominator we have 60 whole square, right? 60 whole square. So what we have is limit t tends to 0, we have 2 minus, if we multiply this function with root 3, so it will become 3 over 2 cos t, right? Similarly, if we multiply by root 3 that particular function, so it will become root 3 over 2 sin t, right? Minus half cos t is there, right? Half cos t is there, minus root 3 by 2 sin t is there, and on the denominator we have 60 whole square, which is nothing but 36 t square, right? So here you can see that root 3 by 2 sin t and root 3 by sin t will be cancelled out, and we have limit t tends to 0. So on the numerator we have 2 minus 3 by 2 cos t, right, minus half cos t, and on the denominator we have 36 t square, right? So let me copy this thing and let me move to another slide, because we have to move to the another slide because we don't have that much amount of space, right, in this particular slide. Just hold on, yeah, okay, now okay, then now we have that particular thing, so that can be written as just hold on, yeah, so that can be written as limit t tends to 0. On the numerator, if we take common cos t, so it will become cos t times, so it will be 3 over 2 plus half, right? And on the denominator we have 36 t square, right? So it will become limit t tends to 0, it will be 2 minus, that will be nothing but 2, right? So it will be 2 cos t, right? And on the denominator we have 36 t square, right? So if we take common 2 on the numerator, so it will become 2 times 1 minus cos t, and on the denominator we have 36 t square, right? So if you just neglect that part, it will become nothing but 18, right? So that will be nothing but limit t tends to 0, 1 minus cos t over 18 t square, right? Now here you can see that 1 over 18 is a constant term, so we can take that 1 over 18 outside of the limit, and it will become limit t tends to 0, 1 minus cos t over t square, right? So you know the formula, right? When limit x tends to 0, 1 minus cos x over x square is obviously similar as limit t tends to 0, 1 minus cos t over t square, because we are just substituting x as t, right? There is no changes. So we can write down this particular thing as half, because we have already proved that limit x tends to 0, 1 minus cos x over x square can be written as half, right? So that will become 1 over 18 times 1 over 2. So that is nothing but 1 over 36, right? This is the final answer of the question, right? Yeah, so this is a very interesting question. What we did actually, we first of all you have to check the substitution method, and I didn't check because I know that substitution method will not work. But you have to check initially, right? So after checking, when you realize that substitution method doesn't work, then you have to use that particular method to solve this question, right? Because that is the easiest and the shortest method you can find out through that total entire lecture, right? For that particular question also, right? So let's move to the next question, and that is very interesting question. So the question says limit x tends to 1 minus x times tan pi by 2x is what? So basically when you put x equals to 1 here, so that part which is 1 minus x is become 0. Similarly tan pi by 2x is nothing but become infinite, right? So it is of the form 0 times infinite, right? And we know 0 times infinite is of is a indeterminate form, right? Is an indeterminate form, right? Indeterminate form. So if it is a indeterminate form, so let me see that here x is actually tends to 1, which is a non-zero value. So let x minus 1 as t, right? X minus 1 as t. So as x tends to 1, where t is going to 0, right? So we can write down this particular thing as limit t is going to 0, 1 minus x is nothing but minus t, because from that relation we have x equals to t plus 1, right? So and also 1 minus x is nothing but minus t, right? Minus t. So 1 minus x can be written as minus t, and that part will be tan pi by 2. X can be written as 1 plus t, right? 1 plus t, right? So negative symbol will be outside of the limit because it is a constant term. So it will become negative limit t tends to 0, t times tan, it will be pi by 2 plus pi by 2 t, right? So now you can observe that on the first quadrant, second quadrant, third quadrant, fourth quadrant, and this particular theorem, pi by 2 plus pi by 2t is nothing but in the second quadrant, and in the second quadrant tan pi by 2 plus theta will be minus cot theta, right? So that will be limit t tends to 0, t times minus cot theta, and theta is nothing but pi by 2t, right? So if we again take the negative symbol, negative sign outside of the limit, so it will become negative times negative will be positive. So it will become limit t tends to 0, t cot pi by 2 times t, right? T cot pi by 2 times t. But we don't have any kind of formula of cot function basically, right? But we have a formula which is limit t tends to 0, t times cot theta can be written as 1 over tan theta. So cot pi by 2t can be written as 1 over tan pi by 2 times t, right? So now you can see that that is nothing but limit t tends to 0, t over tan pi by 2 times t, right? So that can be written as limit t tends to 0, 1 over tan pi by 2 times t over t, right? So if we separate the limit, it will become 1 over limit t tends to 0, tan pi by 2 times t over t, right? So you know the formula, which is limit x tends to 0, tan kx over x is nothing but k. Similarly, if limit t tends to 0, tan k, in the place of k we have only pi by 2. So tan kt over t is nothing but only k, I mean only pi by 2, right? So that is nothing but 1 over pi by 2, which is nothing but 2 over pi, right? So the value of this particular limit is nothing but 2 over pi, right? So you understood what I just did in this particular question. This is a very simple question, right? Yeah. So let's move to the next question. This is also very interesting question. Here you can see that when we put x equals to pi by 2 on the numerator, it will become log 10 pi by 4 with base e, right? So what about the value of log 10 pi by 4? So tan pi by 4 is nothing but tan 45 degree, and you know tan 45 degree is actually 1, right? So log 1 will become 0, right? So log 1 will become 0, so the numerator will become 0. So what about the denominator? When you put x equals to pi by 4, similarly cot pi by 4 will become 0, so it will be 1 minus cot 0, I mean 1 minus 1, so the denominator will also become 0. So it is of the form 0 over 0, but here you can see that x is actually tends to pi by 4, right? And pi by 4 is a non-zero number. Since pi by 4 is a non-zero number, let x minus pi by 4 as t, right? Let x minus pi over 4 as t, right? So if I will take x over pi by 4 as t, just hold on, there is something glitch happened. So if we take x minus pi by 4 as t, so can you tell me what is the value of x? So it is nothing but pi by 4 plus t, right? It is nothing but pi by 4 plus t. So as x tends to pi by 4, so can you please tell me where t will tends to? T is nothing but tends to 0, right? T is nothing but tends to 0, right? So we can change that particular variable x to t, right? What we did in the previous examples also. So it will become limit t tends to 0. So on the numerator it will have log base e, and it will be tan, just wait a second, it will be tan. In the place of x we have pi by 4 plus t, right? Similarly on the denominator we have 1 minus cot pi by 4 plus t, right? Is that right? Is that make sense? Yeah. So basically let me first find out the value of cot pi by 4 plus t, right? Cot pi by 4 plus t. So I will do this thing in that particular solution. So basically it will be limit t tends to 0, so it will be log e. So tan pi by 4 plus t can be written as, you know, right, the value the formula of tan a plus b is nothing but tan a plus tan b over 1 minus tan a tan b, right? So similarly tan pi by 4 plus t can be written as tan pi by 4 plus tan t, right, over 1 minus tan pi by 4 times tan t, right? Similarly on the denominator we can write down this cot function as 1 over tan pi by 4 plus t. Basically there are a lot of students who don't recall the exact formula of cot a plus b, but they have, I also told in the particular some chapters of trigonometry that we don't need to know about the formula of cot a plus b, cot a minus b, if we know the value of tan a plus b, tan a minus b, because through the formula which is known as tan a plus b, tan a minus b, we can easily find out what is the value of cos a plus b, cot a plus b, cot a minus b, right? So it will become limit t tends to 0. On the numerator it will be log e. So tan pi by 4 is nothing but 1 plus tan t, right? and on the denominator we have 1 minus tan t, because tan pi by 4 is nothing but 1, right? Similarly, on the denominator we have 1 minus, it can be written as 1 minus tan pi by 4, right, tan t over tan pi by 4 plus tan t, right? Because 1 over tan pi by 4 plus t can be written as 1 over tan pi by 4 plus tan t over 1 minus tan pi by 4 tan t, right? And that particular denominator will be shifted towards the main function's numerator, right? So that will become limit, it will be t tends to 0, it will become log base e 1 plus tan t over 1 minus tan t, right? And on the denominator we have 1 minus tan t over 1 plus tan t, right? 1 plus tan t. So now we can solve this little bit. It will become log 1 plus tan t over 1 minus tan t, and on the denominator we have 1 plus tan t on the denominator. If we take the LCM, so it will become 1 plus tan t minus 1 plus tan t, right? Is that correct? Yeah. So it will be limit t tends to 0. We can write down that particular thing as 1 plus tan t over 1 minus tan t minus 1, right? And on the denominator we can cancel that per 1, so it will become 2 tan t over 1 plus tan t, right? So now you can see like we can write down this thing as limit t tends to 0. It will be log 1 plus, that will become, if we take the LCM from these two parts, so it will become 1 minus tan t, and on the numerator we will have 1 plus tan t minus 1 plus tan t, right? It is very simple. And on the denominator we have 2 tan t over 1 plus tan t, right? So let me erase that part because you have already written down, right? Okay. So basically from this particular thing we can write down limit t tends to 0 over log base e, it will be 1 plus, this minus 1 and this plus 1 will be cancelled out, so we will have 2 tan t over 1 plus tan t, right? And on the denominator we have 2 tan t over 1 plus tan t, right? Now you can observe that since t tends to 0, what will be tan t? Tan t should also tends to 0, because at t equals to 0, tan t is nothing but 0, right? Similarly, what about 2 tan t? 2 tan t is also tends to 0. So what about 2 tan t over 1 plus tan t? It should be 0, because the numerator will be 0 and the denominator will become 1, because when tan t tends to 0, the denominator, which is 1 plus tan t, is nothing but 1 plus 0, which is 1, right? So denominator should be non-zero. Denominator is non-zero, so we can write down this thing as limit 2 tan t over 1 plus tan t tends to 0, that particular total function, which is known as logarithm of e 1 plus 2 tan t over 1 plus tan t, right? And on the denominator we have 2 tan t over 1 plus tan t. So you can see log 1 plus x over x when limit x tends to 0 is nothing but 1, right? So instead of x we have 2 tan t over 1 plus tan t. So the total value of this particular limit is actually 1, right? The total value of the value of this particular limit is actually 1. So the answer of the question is actually 1, right? So please write down this solution on your paper, so that we will move to the next question, right? So I will wait for a few seconds, then we will move to the next slide. Okay, so let's move to the next slide. There is a lot of formulas. There are actually 4 formulas. The formulas are, when we take the limit as x tends to 0 and the function is actually sine inverse x over x, right? The function is sine inverse x over x. The value of this thing is equals to 1, right? Similarly as sine x over x, but these are actually totally different thing, but here you can understand, right? Limit x tends to 0, sine inverse x over x is equals to 1. So you know, right, what is the value of limit x tends to 0, sine inverse kx over x? We have to multiply by k and divide by k, right? So it will become only k, right? I did the actual proof, right? So, and also limit x tends to 0, tan inverse x over x is nothing but equals to 1, right? So what about the value of limit x tends to 0, tan inverse kx over x? So it is basically only k, right? So tan inverse kx over x equals to k when limit x tends to 0. So let me recall that particular 4 formulas again. The formulas are limit x tends to 0, sine inverse x over x is nothing but 1, and the second formula is limit x tends to 0, sine inverse kx over x is nothing but k, and the third formula says limit x tends to 0, tan inverse x over x is nothing but 1, and the fourth formula is limit x tends to 0, tan inverse kx over x is nothing but k, right? So these are the 4 formulas which we will use in the further questions, right? These are some examples. So this is the first example, and I will suggest you that you should try to solve this question by your own. After that I will give you the solution, so please try to do it by yourself, and I will wait around a minute. After that I will give you the solution. Please try to do it by yourself, please. That is my kind of, you can say, request to you, that please try to do this question by yourself. So I think you have done this, done the solution. So basically here you can see that if we put x equals to 0 on the numerator and the denominator, the numerator will become 0. Similarly, the denominator will also become 0. So this is of the form indeterminate, right? This is actually determinate form, right? This is of the form which is known as indeterminate form. So since we got an indeterminate form, so how we can solve that question? So can you please tell me how we can solve that question? So basically, since it is of the form indeterminate, so we have to divide the numerator and denominator by x, right? Then we will get the previous formula, right? So divide, just hold on, yes, divide the numerator and the denominator by x, right? So if we divide the numerator and denominator by x, so it will become limit x tends to 0. The numerator will become sine inverse 5x minus tan inverse 3x over x, right? Similarly, the denominator will become tan inverse 3x plus sine 5x, right, over x. So we can separate the limit into two functions. So it will become limit x tends to 0. The numerator will be sine inverse 5x minus tan inverse 3x, right? Similarly, the denominator will be limit x tends to 0, over x is there, right? So it will be tan inverse 3x plus sine 5x over x, right? So now we can write down the numerator as limit x tends to 0. It will become sine inverse 5x over x minus tan inverse 3x over x, right? And the denominator will be limit x tends to 0. It will be tan inverse 3x over x plus sine inverse, sine, only sine is there, sine 5x over x, right? So basically we can change the limit into two functions, right? So it will become limit x tends to 0 sine inverse 5x over x minus limit x tends to 0 tan inverse 3x over x, right? And on the denominator we have limit x tends to 0 tan inverse 3x over x plus limit x tends to 0 sine 5x over x. Let me clear one thing, this is not an inverse function, right? So you have to, right, the inverse function in this particular limit formula, the inverse and the general trigonometric function is almost work same, like limit x tends to 0 sine x over x is 1 and limit x tends to 0 sine inverse x over x is also 1, right? And you don't need to think about this thing. So that particular part which is limit x tends to 0 sine inverse 5x over x is nothing but 5, right? Similarly, that particular part will be 3 and on the denominator that particular part is 3 plus 5, right? So 5 minus 3 is nothing but 2 and 3 plus 5 is nothing but 8. So 2 over 8 can be written as 1 over 4. So this is the solution of the question, right? So have you got my point, what I trying to do in this particular question? We are basically divide the numerator and denominator by x, and after that we are applying some little bit algebra and applying the formula and we got the solution, right? Yeah. So let's move to the next question. I mean next theory. This is a theory. The theory says that when limit x tends to a fx to the power gx type function is given to you, right? I mean one function to the power another function, right? So limit x tends to a, fx to the power gx is given to you, and when you put the value of like is of the form 1 to the power infinity, what does it mean actually? It means that limit x tends to a, fx is nothing but 1, and limit x tends to a, gx is nothing but infinity, right? I mean, when we put x tends to a on the function fx, it will give you the value 1, and when you put x tends to a on the function gx, it will give you infinity. So the particular function which is actually limit x tends to a, fx to the power gx is of the form 1 to the power x. Is that right? Yeah. So when we get that particular thing which is 1 to the power infinity, how we can solve this? Because this is nothing but one of the indeterminate form. Sometimes students will say, sir, it is not indeterminate form, it is actually 1. So that's not true. You have to think about it more largely, because infinity is kind of undefined in a very large number or something. How you can say, like you can take multiplication with finite times, but what about infinite times? How you can say, right? How you can say? So basically the method says, the method is limit x tends to a, fx to the power gx is nothing but e to the power limit x tends to a, fx minus 1 times gx, right? This is the formula. Like when we have limit x tends to a, fx to the power gx is of the form 1 to the power infinity, then we can write down the limit function which is limit x tends to a, fx to the power gx as e to the power limit x tends to a, fx minus 1 times gx, right? Fx minus 1 times gx, right? So this is the formula. You have to remember that thing. Sometimes what students is trying to do is, first of all they found the value, they are just find the value limit x tends to a, fx minus 1 to the power gx. After that we just take that particular value on the function on e to the power something, right? Okay, so this is one of the question, which is limit x tends to pi by 2 1 plus cos x to the power tan x. So can you solve this question by your own, and I will give you the solution after a few seconds. So I'm just waiting, like you have to think about that question, then I will give you the solution. Okay, so basically here you can see that x is actually tending to pi by 2, right? So when x is tending to pi by 2, and when you put x equals to pi by 2 on the function, so basically let me take that particular function as fx and that particular function as gx in your mind. So what about limit x tends to pi by 2 1 plus cos x? Can you please tell me? It will be definitely 1 plus cos pi by 2, right? And cos pi by 2 is nothing but 0, so it will become 1 plus 0, which is 1, like, right? So what about limit x tends to pi by 2 tan x? It is nothing but infinity, right? So it is of the form, it is of the form 1 to the power infinity, right? So since it is of the form 1 to the power infinity, so that particular function can be written as e to the power limit x tends to pi by 2 right? Limit x tends to pi by 2, 1 plus cos x minus 1 times tan x, right? 1 plus cos x minus 1 times tan x, right? So that is nothing but e to the power limit x tends to pi by 2, that 1 and minus 1 will be cancelled out. It will have cos x times tan x, right? So that is nothing but e to the power limit x tends to pi by 2. It will be cos x times tan x can be written as sin x over cos x. So that cos x and that cos x will be cancelled out, right? So it will be limit e to the power limit x tends to pi by 2. We have only sin x, right? So when we put x equals to pi by 2 on that particular function, it will give us e to the power sin pi by 2, right? So sin pi by 2 is nothing but 1, so it will be only e. So the value of this particular limit is actually e, right? So let's move to the next question. This is also very interesting question. The question says limit x tends to 0, 3x square plus 2 over 7x square plus 2 whole to the power 1 over x square is equals to, in what the value will satisfy this particular limit. So basically what we have is limit x tends to 0, 3x square plus 2 over 7x square plus 2 whole to the power 1 over x square, right? So basically when we put x equals to 0 on that particular function, I mean, let me write down that thing on that particular area. It will be limit x tends to 0, 3x square plus 2 over 7x square plus 2. When you put x equals to 0 on the numerator and denominator, it will become 3 times 0 square plus 2 over 7 times 0 square plus 2, right? So it is nothing but 0 plus 2 over 0 plus 2, which is 2 by 2, which is nothing but 1. So limit of 3x square plus 2 over 7x square plus 2 is nothing but 1, right? So what about limit x tends to 0, 1 over x square? Since x square is a positive quantity, whether x is tending towards 0 plus or x is tending towards 0 minus, that is nothing but infinity. So this is of the form 1 to the power infinity, right? Since this is of the form 1 to the power infinity, so what will be the solution? What we can write down this particular thing, which is e to the power limit x tends to 0, 3x square plus 2 over 7x square plus 2 minus 1 times 1 over x square, right? So if we calculate little bit, so it will be limit x tends to 0, it will be 3x square plus 2 minus 7x square minus 2, right? And on the denominator we have 7x square plus 2 times 1 over x square, right? So it is nothing but e to the power limit x tends to 0. Here you can see 3x square minus 7x square is nothing but minus 4x square, right? And plus 2 and minus 2 will be cancelled out, and on the denominator we have 7x square plus 2, and we have 1 over x square as multiplication. So that x square and that x square will be cancelled out. So we have e to the power limit x tends to 0 minus 4 over 7x square plus 2, right? So if you substitute the value of x as 0, so it will become e to the power minus 4 over 7 times 0 square plus 2, right? So that is nothing but e to the power minus 4 over 0 plus 2. which is nothing but e to the power minus 4 over 2, which is nothing but e to the power minus 2. So there is no particular thing as e to the power minus 2, but e to the power minus 2 can be written as 1 over e square, right? So here you can see that the option number A is the correct option, right? So please note down the solution of that particular question. We have to move to the next question. So please write down the solution. I will wait for a few seconds, then we will move to the next question. Okay, let's move to the next question. This is also very interesting question, and it's almost same, like you can think about it. So when we put x equals to infinity on that particular area, so what we will have limit, sorry, wait a second, it will be limit x tends to infinity. It will have x square plus 3x plus 1 over x square plus 5x minus 1, right? So since x tends to infinity, it will be the form of infinite over infinite, and you know infinite over infinite is nothing but an indeterminate form, right? So since it is an indeterminate form, so we have already told you, when we have fx over gx type of function of polynomials, then you have to first try to find out the highest degree of that polynomial, right? So since the highest degree of polynomial in highest degree variable is nothing but x square, so you have to divide the numerator and the denominator by x square, right? So it will become limit x tends to infinity. It will be x square plus 3x plus 1 over x square, and on the denominator we have x square plus 5x minus 1 over x square, right? So that is nothing but limit x tends to infinity, right? That particular part will be x square over x square, which is nothing but 1, plus 3x over x square, which is nothing but 3 over x plus 1 over x square, right? Similarly, the denominator will be x square over x square, which is nothing but 1, right, plus 5 over x, right, which is nothing but 5 over x minus 1 over x square, right? So if we put x as infinity, then that particular part will be 0, that particular part will be 0, that particular part will be 0, and that also 0. So it will be nothing but 1 plus 0 over 1 plus 0 minus 0, so which is nothing but 1 over 1, which is nothing but 1, right? So limit of x square plus 3x plus 1 over x square plus 5x minus 1 when x tending to infinity is nothing but 1, right? So what about limit x tends to infinity, x plus 1 over 2, I mean the power part, right? So it is nothing but infinite over 2, it is nothing but infinity, right? It is nothing but infinity. So it is of the form 1 to the power infinity, right? Since it is of the form 1 to the power infinity, that is nothing but e to the power limit x tends to infinity, that particular part minus 1 into times x plus 1 over 2. So it will be very complicated thing. So let me first find out the power part, which is limit x tends to infinity x square plus 3x plus 1 over x square plus 5x minus 1 times x plus 1 over 2, right? So that is nothing but limit x tends to infinity, that part will become x square plus 3x plus 1 minus x square minus 5x plus 1 over x square plus 5x minus 1, right, times x plus 1 over 2, right. So it will, that now you can see that x square and x square will be cancelled out, so it will be nothing but limit x tends to infinity, 3x minus 5x is nothing but minus 2x, right, plus 2, and on the denominator we have x square plus 5x minus 1 times x plus 1 over 2, right. So if we take common 2 from the numerator, then it will become minus x plus 1, which is nothing but 1 minus x, and on the denominator we have x square plus 5x minus 1 times x plus 1 over 2. So 2 and 2 will be cancelled out, 2 and 2 will be cancelled out, and we have limit x tends to infinity, 1 minus x times x plus 1 over x square plus 5x minus 1. So here you can see this is a linear function, this is also a linear function, but when you multiplied them it will become a quadratic expression, right, I mean a quadratic function, right, or you can say a linear expression and quadratic expression, right. So the highest degree variable of the numerator is nothing but x square, and also the highest degree variable of the denominator is nothing but x square. So we have to divide the numerator and denominator by x square, right. So when we divide the numerator and denominator by x square, so it will become 1 minus x times x plus 1 over x square, and on the denominator we have x square plus 5x minus 1 over x square, right. So it is nothing but limit x tends to infinity, the numerator will be can be written as 1 minus x over x, right, times x plus 1 over x. Similarly the denominator will be x square over x square plus 5x over x square minus 1 over x square, right. So that is nothing but limit x tends to infinity, that is nothing but 1 over x minus 1, right, times 1 plus 1 over x, right. Similarly the denominator will be 1 plus 5 over x minus 1 over x square. So as x tends to infinity, that 1 over x will become 0, that 1 over x will become 0, that 5 over x will become 0, and 1 over x square will become 0, right. So that is nothing but 0 minus 1 times 1 plus 0, which is nothing but negative 1, over it will be 1 plus 0 minus 0, which is nothing but 1. So that is nothing but negative 1. So most of the people will say that the value of that particular limit is nothing but negative 1, but that's not true. Basically what we messed up is actually the e to the power function, e to the power limit x tends to infinity, that particular function into x plus 1 by 2 will be there. So we have just find out the value of that particular limit, which is nothing but e to minus 1. So the value of this particular thing is actually e to the power minus 1, which is nothing but 1 over e. So this is the exact solution, or you can say this is the correct solution of the given question, right? So okay, so you can try these questions by yourself. These questions are for your homework, and we will discuss these questions for the tomorrow's lecture. Okay, so you can try to do this by your own, and we will discuss these questions in the upcoming lecture. Okay, till then stay tuned with us, and comment below that what type of suggestion you will give us, and also what topic you want in the next lecture. Okay, and thank you for watching this video. We will meet soon. Thank you.